Hello guys, thank you for staying here in my speak name and implementation of Bernstein method in Neuromorphic system for the execution of the speaking neurons. Presents Álvarez-Sánchez Teodoro, Aguilar-Sánchez Abiel, Álvarez-Cedillo, Jesús Antonio, and Morales-Navarro, Néstor Antonio from the National Politécnico Institute. The numerical computing seeks to create hardware and software that can adapt and perform complex tasks similarly to how the biological brain learns, making it in the interdisciplinary field of research that combines neuroscience and computer system engineering. Research areas in neuromorphic computing offer several benefits and efficiency, adaptability, power consumption, robustness, and innovative application, making then existing and promising for the future and computing and artificial intelligence. The neuromorphic computing offers benefits in using conventional artificial intelligence, advanced digital signal processing, and probabilistic model-based computing. These alternatives provide unique applicability, efficiency, and robustness benefits, making it a viable option in computing and evolution of an artificial intelligence. However, neuromorphic computing offers a promising alternative which face significant challenge and they must be addressed to realize in the full potential. The neuromorphic computing seeks to create hardware and software that can adapt and perform complex tasks similarly to how the biological brain learns, making it is an interdisciplinary field of research that combines neuroscience and computer system engineering. Research areas in neuromorphic computing and offers several benefits and efficient adaptability, power consumption, robustness, and innovative application, making them existing and promising on the future of computing and artificial intelligence. The incorporation of speaking neurons and speaking networks offers one alternative and good and best alternative for the traditional artificial neural network approach by modeling biological neural activity with pulse or spikes. These neurons and spike network offer more favorable representation of biological neural computation, which can lead a more efficient and adaptive system. In neuromorphic computing, this approach seeks to emulate brain functionality by developing specialized hardware and software that can perform tasks more efficiently and autonomously, open up the opportunities for new artificial intelligence and robotics algorithms and other related in their application in other related areas. Compared with the old numeric computing, more than intense high throughput concepts, the neurons and speaking network approach includes great design complexity and computational and memory resource requirements. In addition, adapting algorithms and support existing hardware can pose additional challenges, which could limit the data scalability and performance in large-scale applications. In the equation number one, the skip neuron is mathematically defined by Kim at 2022. In the future 2, 3, and 4, we present neurons, spec neural networks, topology, and event-based networks. By other hand, in the many-core system, the many-core system addresses how architecture, programming models, and energy efficient performance optimization. In addition, concepts in Safari and reality on Epiphany 4 are adopted. The Epiphany 4 is a motherboard special used for these uses. Many core systems function in designing, implementation, and optimizing hardware architectures with multiple processing cores. These systems to maximize performance and efficiency for the distribution and tasks between cores, the optimization of memory access, and energy management. The Bernstein model, which approximated polymerase and interpolated Gibbs point, can be efficiently adapted to parallel execution to improve performance and reduce calculation time. In this parallel approach, the work is divided into small sub-intervals for distribute across multiple processing units. A subinterval is assigned in computational tasks, calculating the corresponding Bernstein polynomials and evaluating the original function in points with that subinterval. These tasks run simultaneously in different cores or processors, allowing for high performance efficiency. Once the parallel and concurrent runs are completed, the partial results of each subinterval are collected and combined to obtain final approximation. During the parallel execution, it is crucial to establish synchronization and communication mechanisms for ensure proper access to shared resources and data exchange between parallel execution. The proposal of the edge neuron in the neuromorphic computation acts is in a nucleus similar to that of the medical system. In this environment, a neuron plays a role equivalent to that the nucleus in the medical system. That the massive distribution on processing units, similar to how multiple cores operate in the medical system in parallel systems. The medical system simultaneously processes specific tasks, leveraging parallelisms, capabilities for improve overall performance. As mentioned in the previous paragraph, the proposal to adapt concept of medical system to the neuromorphic system. In this system, each neuron performs calculation and processing independently and concurrently, this contributing in computational processing. In addition, the neuromorphic system on the company branch chip has similar distribution to hardware in the medical system, where the core are interconnected and to allow communication and exchange data between them. The branch-chip process microprocessor. In the branch-chip microprocessor, the relation between the system is analyzed in the internal hardware level and is observed. Which is similar, then the neurons are interconnected in neural networks that facilitates the transmission of signals and collaboration in information processing. How result this research project? The section will use the Bernstein method for read and write operation for the parallel execution with concurrency problems. This operation constitutes the settlement of instruction carried out in parallel. Along this current and sequential execution, specifically designed implementation and neuromorphic system with many concepts. As artificial neuron in the neuromorphic system will execute instruction. The evaluation of the execution of this instruction can be carried out in various ways. One, the programming the speaking neuron in the neuromorphic system is only outside the compilation and execution errors. The application of Bernstein methods and verifiable parallel execution. And three, verification and analysis of the checks for the execution model and its possible conflicts. Conclusion. The contributions of this research are the following. Bernstein conditions were developed and analysis provided did understanding principles governing parallel execution. On detailed comparison of Bernstein properties were made evaluating their application in list one and having this application for efficient execution in parallel execution. The parallel execution of the artificial speaking neurons was observed, confirming and they complete with the Bernstein properties and validating this viability in neuromorphic environment. The research goal is to verify and demonstrate the successful execution of artificial neurons in a morphic system, which check for similar conflicts in parallel execution and examining when the conflicts arise when trying to accept shared computer space in the shared memory. It was verified too that the only one space can be accessed in the time, which can be crucial for understand limitations and possibilities and their neuromorphic system with artificial neurons and their path. We thank the Descartes University of Science and Technology UNAM for supporting the doctoral research and the National Politécnico Institute in Mexico and the Secretariat of Research and Postgraduate Studies with the projects 2024-43 and 2024-1946 projects, like with the Program for Encouragement on Research Performance (ADA), and the Commission for the Operation and Promotion of Academic Activities for the National Polytechnic Institute. There are our references used in the same of this project. Thank you very much. For any question, please send me an email to galvarez.ipn.mx. Thank you very much.